beautiful people, and welcome. In today's video, we will be discussing perpendicular lines. This is an introductory video, so we're going to be talking about how to determine if two lines are perpendicular and also things that we need to know about slope and the perpendicular lines characteristics. As a disclaimer always, I am human, so if I make a mistake, I apologize. Just let me know where the mistake occurs so that way we can learn from my mistake. All right, let's get started. Now, perpendicular lines are lines that cross, and they cross in a very specific way or a very specific angle. So lines that cross, and they cross at a 90-degree angle. And so remember, 90 degree is a right angle. And we show that it is right angle by putting a little box where the angle are. How do they look like? So perpendicular lines look like something like this. So let's say here's your X and here's your Y. And let's say we're going to sketch a graph of perpendicular lines. So here's line 1. And here is line 2. I'm going to find a different color. So these two lines are perpendicular. How do we know they're perpendicular? Because they meet at a 90-degree angle. So it's completely different from parallel lines. Parallel lines, if you saw the previous video, are lines that never, ever, ever touch because their slope is the same. And then perpendicular lines are lines that not only do they meet, but they meet at a 90-degree angle. I'm not sure if you heard that, but Miss Sylvanas is being very talkative in the background. I apologize for that. All right, so not only do perpendicular lines meet, they meet at a very specific angle, at a 90-degree angle, which means what for their slope? So because they meet at a 90-degree angle, the slope, let's do their slopes, they're different. They have to be different because the rate of change, rise over run, is not the same because they actually do meet. So their slopes are negative reciprocals. Now, I personally don't like to use negative reciprocals. I will not be using the term negative when I refer to the slope of perpendicular lines. What I will do is I will refer it to as opposite reciprocals. My personal opinion, a negative confuses students because it is not always negative for the slope, but it is opposite of whatever you have. For example, if you have line 1 and you have line 2, and in line 1, your slope is equal to 5, and line 2, your slope has to be opposite and a reciprocal. So what does it mean to be opposite? Let's change colors. Here's a thinking bubble. Opposite means you change your sign. And what does it mean to change your sign? Well, that means if it's a positive, you go to a negative, and if it's a negative, you go to a positive. Okay, so if it's a positive, you go to a negative. If it's a negative, you go to a positive. That's what we mean by opposite. Now, reciprocal means you flip your fraction. So we're going to say reciprocal. We flip fraction. Ran out of room there. And what does it mean to flip fraction? Let's see if I can quickly show you here. I'm going to cut some things out just really quickly. So let's say we have a fraction, and our fraction is, let's do 3/4. Here's our fraction, 3/4. So when we take the reciprocal of that fraction, we take the top number, the number in our numerator, and we put it on the bottom. We flip it. So so here's our fraction, take the reciprocal, flip it. This is our fraction, take the reciprocal, flip it. So when you take the reciprocal of a fraction, that means you flip the two numbers, switch their position. Okay? Now, looking at our first example, 5 is not a fraction technically. So if it is not a fraction, you make it a fraction by putting 1 underneath. So now we have a fraction. So now we have 5 over 1. So now we need to do two things in order to have a perpendicular line, or the slope of a perpendicular line. So the first thing we need to do is we need to take the opposite. So what is the sign of 5 over 1? Well, it is a positive number, so the first thing we need to do is change it from a positive to a negative. Second thing we need to do, so that's the first thing. Second thing we need to do is take the reciprocal, again, flip it. So I'm going to flip my numbers, and now I have 1/5, 1 on top, 5 on the bottom. And these two slopes tell me that I have perpendicular lines. Okay. Now, let's do an example. Let's call this example 2. Let's call it example 2. Now, if you haven't already, go ahead and watch the parallel lines video. In that video, I show you a brief example on how to find slope. We're going to use the slope formula in this example as well. So I want you to find the slope of line PQ. We know it's a line. I'm going to put a line on top. And RS. Okay, so how do we do that? Here's PQ. P is -3/14, and Q is 2 and -1. I'm going to split this. RS is 4 and 8, and -2, -10. Just like we did in our previous video, we're going to label these. So this is X1, Y1, X2, Y2. Let me switch colors. I can color code X1, Y1, X2, Y2. Our slope formula is Y2 minus Y1, X2 minus X1. I'm going to rewrite that and then leave space to fill in with my actual numbers. So what are my actual numbers? Y2 is -1. Y1 is 14. X2 is 2. X1 is -3. Again, if you have two negatives right next to each other that you can circle, that means it is a positive value. So we're going to change it to a positive. If you cannot circle the two negatives and you cross out a number, leave it. It does not convert to a positive. So what do we have here? I have -1 minus 14. I have 2 plus 3. -1 and -14, that is -15. 2 plus 3 is 5. Remember to simplify. I know, keep your negative if you have a negative. So -15 is 3 times 5. And then down at the bottom, I just have a 5. I have a 5 on top, 5 in the bottom. We're going to divide that. So our slope is -3. You can put a 1 underneath because we will be checking for the reciprocal, so you would need a fraction. Okay, so that's our first slope. We're going to do exactly the same thing for our secondary slope. All right, so make sure you leave some space. Okay, what is x2? x2 is negative 10. Excuse me, I called this an x. It's a y. y2 is negative 10. y1 is 8. x2 is negative 2. x1 is 4. Is there anything that I can circle? No, there is not. So I have negative 10 minus 8. And I have negative 2 minus 4. All right, let's check. Simplify this. I have negative 10 and negative 8. That means I have negative 18. Negative 2 and negative 4. That means I have negative 8. Excuse me, negative 6. And I need to simplify that. My negative stays. 18 is 6 times 3. I have 6 on the bottom. My negative stays. Here's my 6. Negatives cross out. 6 cross out. What am I left over with? I'm left over with 3. So my slope is 3 over 1. So now we have to check. Are they opposites of each other? So is one positive? Is one negative? Yes. This line slope, this slope is positive. This slope is negative. Are they reciprocals of each other? Did the fraction flip? No. I have 3 over 1. I have 3 over 1. So the fraction did not flip. Therefore, our conclusion, our answer is not perpendicular. You can just say not perpendicular. They have to be both opposites and reciprocals. All right, and now we're working on example number 3. In example 3, we want to determine whether the equations are perpendicular. So here's our example. We have y equals negative 3 halves x plus 4 and y equals 2/3 x minus 7. So when you are determining if the equations are parallel, you're looking at the number in front of x. That is your slope. And then for your slope, we want two things. We want them to be opposite. So again, if one is positive, one is negative, doesn't matter which one's which. And then we want the second part to be reciprocals. And that is where your fractions flip. Okay, so let's ask ourselves, are these opposites of each other? Is one positive, is one negative? Yes. This one is negative, this one is positive. So check here. We can do a mental check. I'm not actually going to write a check mark. The second thing, did the fractions flip? Is 3 on top and 3 on the bottom here? Yes. Is 2 on the bottom, 2 on top here? Yes. So if they meet both requirements, you can say that yes, they are perpendicular. Let's do another one. Y equals 5x plus 2 and y equals 5x minus 1. Again, what are we doing? We're checking. We're checking that number in front of x. And right away, I can see, excuse me, guys. Right away, I can see that 5 and 5 are exactly the same number. If you recall, if the slope is exactly the same, that means that the lines are parallel. And let's do one more. Let's do y equals negative 4x minus 2, and y equals 1/4 x plus 5. Again, what are we doing? We're looking at the number in front of x with the sign. So 1 is negative, 1 is positive. Let's shift this up, I apologize. 1 is negative, 1 is positive, okay? And then let's convert 4 into a fraction, put a 1 underneath it. So I have a negative 4 over 1, and I have 1 over 4. So you can see that the numbers have flipped. So yes, these two equations, these two lines are perpendicular. All right, guys, this wraps up this video. If you have any questions, please let me know. As always, I appreciate you watching these videos. If you can like, share, and subscribe, tell your friends about them, I would truly appreciate it. As always, if you catch a mistake, I apologize. I am human. Just let me know where the mistake occurs so we can learn from that. Thank you again for watching, and I'll see you in my next video.